Okay, so we're going to kind of call this, I'm going to call it 9.2 AA. It's the second day of 9.2, if you will. We need to find the least common multiple. In other words, the LCM. And also, the LCM is also known as the LCD. What does LCD stand for? Least common denominator. Least common denominator is actually your least common multiple, but we need to find that for when we get to solving, okay? We're also going to do some more excluded values, because those are always important. Okay, you ready? What is the LCM, or the least common multiple, of 2 and 3? How would I find the least common multiple, or the common denominator, however you want to think about it, if 2 and 3 are the numbers that I'm looking to find the least common multiple of? You could do a factor tree, but 2 and 3 are both prime. So their factor tree is kind of a seed. That's it. Does anyone know how to do that? The way you would have learned it in elementary school would have been you count by 2s. And you count by 3s. And the least common multiple is the smallest number that's on both lists. So what's the smallest number on both lists? Therefore, 6 would be considered the least common multiple, or the least common denominator, of 2 and 3. Now, I will get people that will say, do I just multiply them together to get the least common multiple? Do I just multiply the numbers together? Well, to be specific, if you multiply the two numbers together, you will get a common multiple that will work, but it's not always the least common multiple. So you may end up with bigger numbers that make it a little trickier to do the rest of the process with. Does that make sense? Good answer. So what if I took that a little bit further and I said find the LCM of 2AB and 3C? Well, I know the least common multiple of 2 and 3 is what? 6. As soon as we get letters, we have to, in a sense, you're squishing them together. You're including all of them. In other words, I need to see every part of this in my LCM and every part of this in my LCM. So if there's an A anywhere, there must be an A here. If there's a B anywhere, there must be a B here. And if there's a C here, there must be a C over here. Does that kind of make sense? In other words, I should be able to take that LCM, 6ABC, I should be able to divide it by 2AB and get a nice number. Do I get a nice number? 3C. And I should be able to take 3C and divide it by, I should be able to take 6ABC and divide it by 3C and get a nice number. So that gives me 2AB. Yes. Yeah. Does that make sense? Okay. So that would be my LCD, or my LCM of that. Let's try 36 and 56. Can you find the least common multiple? A lot of people get the least common multiple mistaken with the greatest common factor, right? Greatest common factor would be a number less than these. Greatest common multiple, or least common multiple, sorry, is a number bigger than them. So I'm not looking for the biggest number they can both be divided by. I'm looking for the smallest number that would be on both of their lists if I was counting. Any ideas? You might want your calculator. I'm getting mine. 108. 180. I'm going to stop right there and hope that I catch up with something. 56 plus 56. 112. 168. Crikey, this is going to be a long one, isn't it? Getting any closer? It's taking me a bit, isn't it? So what can I do? Well, let's do an easier way. Let's start with our factor tree. 36 is what? 2 times 18. I like to do 2's because they're easy. 2 times 9, 3 times 3. So in other words, 36 is the same as 2 times 2 times 3 times 3. Would you agree? 2 times 2 times 3 times 3 is the prime factorization of 36. Yes? Let's do the same thing for 56. What does 56 break down into? 2 and 28, 2 and 14, 2 and 7. So this is 2 times 2 times 2 times 7. So let's see. 2 times 2 times 2 times 7 is 56. So I have it. Okay. All right. So can I rewrite these slightly different? 2 squared times 3 squared. And this one I would say 2 to the third times 7. Are you okay with what I have there? So my least common multiple, I'm going to treat kind of like the A, B, C's up here. I have to include each number. You notice that 2 is represented twice. When you have something represented twice, you always take the higher exponent. So I have 2 squared and 2 cubed. I'm going to take 2 cubed. There's a 3 squared represented. I need to take 3 squared. And there's a 7 represented. I need to take a 7. What does that get me? 2 to the third times 3 squared times 7. 504 is the least common multiple of those two numbers. That would have taken me a while to do this way, wouldn't it have? This is a faster way to go about it if you have the prime factorization, and you can do that. So? Okay. So now let's see if I can add a little bit more to it. So what's my LCM there? You know it's 504, because we just did that. But then how do the x's and y's and z's? I have x squared and x. I'm going to take the x squared. I have a y, and I have a z to the third. That's my least common multiple. Capiche? All right, let's see if we can get a little trickier. Find the LCM. I'm sorry, the least common denominator. These ones are written as denominators. So there's one fraction. Here's another one. First off, it'd be easiest to do the excluded values, wouldn't it? What's the excluded value here? -2, and here? So those are my excluded values. That's easy. Up here, I didn't have to worry about excluded values because I wasn't talking about fractions at all, was I? Okay. So can this denominator be factored? No. So I'm going to put it in parentheses. Can this denominator be factored? So I'm going to put it in parentheses. My LCD, or in other words, the least common multiple, of the denominators is going to be, I have to treat each parentheses the same way I treated the numbers here and the same way I treated the letters here. So I have an x plus 2 represented. It has to be in my LCM. I have an x plus 4 represented. That has to be in my LCM. That's my least common denominator, or my least common multiple. By the way, the reason why we need the least common multiple is because when we are doing fractions in equations, when we have equations of these ugly fractions, this is going to be our trick to getting rid of the fractions so that we're just dealing with nice numbers. Okay? We good there? Okay, let's try this one. What do you notice about this one? I can factor this denominator, can't I? So what if instead of calling this fraction this, what if I called it, does that mean the same thing? So let's look at the factored form of that fraction instead. So now, can x plus 2 be factored? No. So my LCD, or my LCM of the denominators, there's an x plus 2 represented. Yeah? It's represented here also. Which one has the higher exponent? Well, the exponents match, so I just take it with the first power. I do not need to take both of them, right? Just like up here with the 2's, I didn't take both of them. I just took the one with the higher exponent. Okay? These ones, they both have the same exponent, so I just take that exponent. I also have a 2 out in front, which means my LCD must have the 2 out in front. Is there any part of these denominators that I'm missing in my LCD? So that is my LCD. So? This process gets a little tricky, so we're practicing the way several of them look. Okay, here we go. There's my first fraction. There's my second fraction. What do you notice about these two fractions? They can both be factored. Yes? So that's the first step. Factor these denominators. 6 and negative 5, what would my two numbers be? Negative 3 and negative 2. So this fraction is really x minus 3, x minus 2 on the bottom. Yeah? What about this one? Negative 3 and negative 3. So this is really 1 over x minus 3 squared, right? So my LCD, or the LCM of the denominators, notice I have x minus 3. I'm going to take the one that has the bigger exponent, which would be the squared, right? So x minus 3 squared. And what else? The x minus 2. Now, remember how I said earlier that you could just multiply the denominators together? That would be, if I included the squared and the regular one, that would give me a cubed over here. Yes, that's a common denominator, but it's not the least common denominator, so it's giving you extra stuff that you don't need to deal with. Okay? All right, you try this one. Sorry, that's not a plus, a minus. 3x minus 15 and factor those denominators completely and then see what the LCD would be. Is that what you got for the first denominator? Is that what you got for the second denominator? Okay, so I factored it once, factored it twice. My LCM. Well, what is not in a parentheses that I need to include? 3 and x. X minus 5, they have the same exponent, so I just take that exponent. And what else? X plus 2. So? Oh, this one's so mean. I don't want to do that one. Okay, let's do this one. I'll call this one our last one. So let's see, 1 over 3x plus 15 and 1 over 4x minus 20 and 1 over x cubed minus 25x. I gave you an extra fraction there, which means that everything represented in the 3 denominators has to be in my least common denominator. How does this one factor? 3 and x plus 5, right? This one is 4 and x minus 5, yes? This one, if I take out an x, I have x squared minus 25, which can go further, can't it? X and then x plus 5, x minus 5. So let's see, my LCD, what is not in a parentheses? An x and a 3 and a 4. So the 3 and the 4 I have to treat like that first example way back at the beginning. If I count by 3s and I count by 4s, what's the smallest number on both lists? 3, 6, 9, 12. So 12 is the LCD of those two. And there's an x. And then what are the parentheses represented? X plus 5, and the highest exponent is just x plus 5, right? There is no exponent. And then x minus 5. So that's the LCD of all 3 of those fractions. Capiche? Now, I didn't ask you about them. Shame on me. But if I wanted to ask you about excluded values, if I went back to number 6 here, I get my excluded values from that LCD. What would my excluded value be here? X cannot equal -2. What about up here in number 7? Go to your LCD. X cannot equal what? 3 and 2. Right here, x cannot equal what? 0. That's from out here. 5 and -2. And from here, x cannot equal 0 and positive and -5, right? Easy peasy, right? So your homework is just going to be practicing getting the LCD in these various situations and stating the excluded values. Okay? All right. Happy studying.